Eigen Institute of Engineering and Technology. Today we are going to discuss a few more topics of system of linear equations and matrices. So let's begin with the first topic, that is eigenvalues and eigenvectors. So let A be any square matrix. Okay, here we are considering a square matrix of order n. So if there exists a non-zero column matrix X and a scalar lambda such that Ax is equal to lambda x, then lambda is called eigenvalues of A, and a non-zero column matrix capital X is called an eigenvector corresponding to lambda. These eigenvalues are also known as characteristic roots or latent roots or spectral values or proper roots. Okay. Now we will write this Ax is equal to lambda x from this. Ax is equal to lambda x. Okay. So this we can write as Ax is equal to lambda Ix, where I is a unit matrix, or you can say it is an identity matrix, right? Now we will bring this lambda Ix to the left side. So you will get A minus lambda I into x. Take this x common. Okay. So this is equal to 0. Now the matrix A minus lambda I is called eigenmatrix or characteristic matrix, and this determinant A minus lambda I is called eigenpolynomial or characteristic polynomial. It is a polynomial of order n in lambda. Okay. Now the equation determinant A minus lambda I equals to 0 is eigenequation or characteristic equation of A. Okay, so we will use this characteristic equation to find the roots. So the roots of determinant A minus lambda I equals to 0 are called eigenvalues of a matrix A. Right? Now we will study the properties of eigenvalues. So the first property is sum of eigenvalues of a matrix is the sum of its principal diagonal element. Okay, that is the trace of A. So let's study using one example. So suppose here we have 1, 2, 3 and 4. Right, this is a matrix, and suppose the eigenvalues are 1 and 4. So this is our principal diagonal. Okay, so we have to add them. So add this element, that is 1 plus 4. This is 5. Okay, so this statement says that the sum of principal diagonal element is equal to what? Sum of eigenvalues, and the sum of eigenvalue is also 5. Right, so this is just an example to show the property of this. Okay, now the second property is the product of eigenvalues of a matrix is the determinant of a matrix. Okay, so if you will find the determinant of any matrix, it will be equal to product of eigenvalues, means multiplication of eigenvalues. Okay, now the eigenvalues of a triangular matrix are the diagonal elements of the matrix. Now let's study what is a triangular matrix. So there are three types of triangular matrix. First one is upper triangular. Okay. So the matrix is of this form. Suppose 1, 2, 3. Here we have 4, 5, 6. And here we have 0 elsewhere. Right. So here a triangle is formed like this. This is the upper triangular matrix. So whenever we have such type of matrix, the eigenvalues will be the diagonal elements of the matrix. So the diagonal elements are what? 1, 4 and 6. Right. So this will become the eigenvalues of a matrix. Next is lower triangular matrix. Okay, so here we have the matrix like this. Here we have elements 1, 2, 3, suppose 4, 5, 6. Okay, and here we have 0 here. So this is our lower triangular matrix, right? And the eigenvalues will be this diagonal elements, that is 1, 4 and 6. And triangular matrix means we have element only in this diagonal, else everywhere we have 0. So this is a triangular matrix and the eigenvalues will be 1, 2, 3. So you can directly write the eigenvalues from this triangular matrix. Okay, now the next property is the eigenvalues of two matrices A and A transpose are same. Now A transpose means what? You can interchange the rows and columns. So for example, we have matrix A as 1, 2, 3, 4, right? So the A transpose will be 1, 3, 2, 4 like this. You can interchange the row. This first row will become the first column and the second row will become second column, right? So this is A transpose. So this property states that the eigenvalues of A and A transpose are same. Okay. Now the next property is the eigenvalues of A inverse are the reciprocals of eigenvalues of A. Okay. So if lambda is the eigenvalue of matrix A, then 1 upon lambda is an eigenvalue of A inverse. Next, if lambda is an eigenvalue of matrix A, then lambda raised to k is eigenvalue of A raised to k, where k is an integer. Next is, if lambda is an eigenvalue of a matrix A, then lambda plus or minus k is eigenvalue of A plus or minus ki, where k is integer. Next property is, if lambda is the eigenvalue of a matrix A, then k lambda is eigenvalue of k, where again k is integer. Okay, so we will briefly write this all properties. So suppose we have a matrix A and the eigenvalue of this matrix A is lambda. So the eigenvalues of A transpose will be same, that is lambda. Okay, the eigenvalues of A inverse, it will be 1 upon lambda, right? Then the eigenvalues of A raised to k will be lambda raised to k. Eigenvalues of A plus or minus ki will be lambda plus or minus k, and eigenvalues of ka will be k lambda, right? So these are the properties from 4 to 8. Next is, matrix A and A transpose need not have same eigenvectors. Now, next is characteristic equation of a matrix. The characteristic equation of a square matrix A of order 2 is given by lambda square minus s1 lambda plus s2 is equal to 0. Okay, so this we can get from determinant A minus lambda I equal to 0. Okay, so this is the shortcut technique to find eigenvalues. So the characteristic equation for a 2 cross 2 matrix is this, that is lambda square minus s1 lambda plus s2 is equal to 0, where s1 is equal to sum of principal diagonal elements, that is trace of a matrix. Okay, this principal diagonal elements we have to add them and this will become your s1. Next, s2 is what? Determinant of a matrix A. Okay, we have to substitute the s1, s2 and we have to find the value of lambda, and that lambda will become your eigenvalues. Okay, now next, the characteristic equation of a square matrix A of order 3. So we have a 3 cross 3 matrix. So equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0, where s1 is equal to sum of principal diagonal elements of A. S2 is sum of minors of principal diagonal elements of A. This we will study in example. Okay, and S3 is what? Determinant of A. So we have to find this S1, S2 and S3. We have to substitute in this equation and we have to solve this equation. So you will get the value of lambda, and the value of lambda will be your eigenvalues. Okay, so now let's begin with the example. If matrix A is given, then find the eigenvalues of the following matrices. The first one is A transpose, A inverse, A square, 5A and A plus 2I. So let's begin with the solution. Your matrix A is given. Okay, so firstly we will write the characteristic equation, which is given by determinant A minus lambda I equals to 0. Okay, so this is our lambda and we have to minus lambda I, that is 1, 0, 0, 0, 1, 0 and 0, 0, 1. Okay, so here we have minus lambda, lambda and then add them. So you will get here 3 minus lambda, 5 minus lambda and 3 minus lambda. all other places we have 0, so all other elements will remain same. Only we will get changes here. Okay, now we will write the characteristic equation directly using this formula, that is lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0, where s1 is what? Sum of principal diagonal elements of A. Okay, now the matrix A is what? It is 3 minus 1 1 minus 1 5 minus 1 and 1 minus 1 3. Okay, this is our matrix A. Now firstly we have to find S1, that is sum of principal diagonal elements. So principal diagonal elements are 3, 5 and 3, right? So just add them, so you will get answer 11. Next, we will find S2. S2 is what? Sum of minors of principal diagonal elements of A. Okay, so we have to find the minors of 3, 5 and this 3, and we have to add them. So firstly we will find the minor of this 3. So for that we have to hide this row and this column. So you will get 5 minus 1 minus 1 3. Okay, plus now we will find the minor of this 5. So for that we will hide this row and this column. So you will get 3 1 1 and 3, right? Plus now we will find the minor of this 3. So for that we will hide this row and this column. So you will get 3 minus 1 minus 1 5 here, right? Now we will solve determinant. So you will get here 15 minus 1 plus 9 minus 1 plus 15 minus 1. Simplify this, so you will get answer of S2 as 36. Okay, now we will find S3, that is determinant of a matrix A. So matrix A is given, so we will find its determinant. First we will keep 3 as it is. Now here 15 minus 1 plus, here we have minus. Okay, so this minus minus will become plus. So plus 1 into here minus 3 plus 1. So you will get like this. Plus 1 into here 1 minus 5. Simplify this. So you will get the answer of S3 as 36. Okay, now we will substitute the answer of S1, S2 and S3 in characteristic equation, that is lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. Substitute, so you will get this cubic equation. Now our task is to solve this cubic equation. Okay, so firstly what we will do, we will substitute the different values of lambda and we will check whether the answer is 0 or not. So let's begin with lambda is equal to 1. Okay, so in this equation just substitute 1 in place of lambda. So you will get here 1 minus 11 plus 36 minus 36, right? So this is what? Minus 10, right? Which is not equal to 0. So this 1 is not the root of this cubic equation. Okay, so we have to check for different lambda. So suppose take lambda is equal to 2. Okay, so for lambda is equal to 2, what you will get here? 8. Then here minus 44, then plus 72 and minus 36. If you will simplify this, so you will get answer 0. So we can say that this lambda is equal to 2 is what? It is a root of this equation. Okay, so we will solve this using synthetic division. So 2 we will keep here and here we will write the coefficient of this lambda, that is 1 minus 11 36 and minus 36. So 1 minus 11 36 and minus 36. Okay, now we will write 0 here and we'll bring this 1 here. Now we have to multiply here, right? So 1 into 2, so we will write 2 here. Now we will add them. So minus 11 plus 2, so you will get minus 9, right? Now we will multiply this minus 9 with this 2, so you will get minus 18. Thus this we will write here. Okay, now 36 minus 18, it will give you 18. Okay, now 18 into 2, so it will give you here 36. Add them, so it will give here 0. Okay, so this is our cubic equation. So here we have a quadratic equation as lambda square. Just substitute here lambda. So lambda square minus 9 lambda plus 18 is equal to 0. Now we will solve this quadratic equation. So you will get the root as lambda minus 2, lambda minus 3 and lambda minus 6 equal to 0. Okay, and from this you will get the answer of lambda as 2, 3 and 6. Okay, so this is the eigenvalue of a matrix A. Now, the eigenvalue of a matrix A, that is lambda, this is 2, 3 and 6. Now we will find the eigenvalues of A transpose. So here we will use the properties. So the eigenvalues of A transpose is what? Lambda. So again it will be same, that is 2, 3 and 6. Next, the eigenvalues of A inverse, that is lambda inverse, that is 1 upon lambda. Okay, so the answer will be 1 upon 2, 1 upon 3 and 1 upon 6. Next, the eigenvalues of A square, it will be lambda square. So just we have to square this. So you will get 4, 9 and 36. Next, eigenvalues of 5A, that is 5 lambda. So here we have to multiply it by 5. So you will get 10, 15 and 30 as the eigenvalues of 5A. Next, we'll find the eigenvalues of A plus 2A. So this will be lambda plus 2. So here we have to just add 2 everywhere. So you will get 4, 5 and 8 as the eigenvalues of A plus 2A. Okay, so here we have used that properties to find the eigenvalues of this A transpose, A inverse, A square, 5A and A plus 2A. Okay, now let's move to one more example. If A matrix is given and we have to find the eigenvalues of this matrix. So let's begin with the solution. Here A matrix is given. Now you can see this matrix is upper triangular matrix. Okay, so we will use the property. So whenever we have a upper triangular matrix, the eigenvalues will be the elements of principal diagonal elements. Okay, so here the principal diagonal elements are 1, 2 and 3, right? So the eigenvalues of this matrix is 1, 2 and 3. Okay, so whenever we have a triangular matrix, we can directly write the eigenvalues by this diagonal elements. Okay, so in today's session we studied eigenvalues and eigenvectors. So firstly, to find eigenvalue, what we have to find is determinant A minus lambda I equals to 0. This is the characteristic equation. Okay, now we have a shortcut technique for 2 cross 2 matrix and 3 cross 3 matrix. Okay, so for 2 cross 2 matrix, the characteristic equation is lambda square minus s1 lambda plus s2 is equal to 0, where your s1 is what? Sum of principal diagonal element and s2 is what? Determinant, right? And for s3, the characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0, where s1 is what? Sum of principal diagonal element, s2 is what? Sum of minors of principal diagonal element, and s3 is what? Determinant, right? So we have to find for here s1, s2 and just substitute, find the value of lambda. So that will be the eigenvalues. And here also we have to substitute the value of s1, s2 and s3, and we have to find the value of lambda, and that lambda is your eigenvalues, right? So I hope you have understood in this session. Thank you for watching.